Good evening, everyone. It's so nice to have you today. I hope you are doing well. I know that this is the end of the day and you have a day of work before, but I'm hoping that I can keep you entertained for today and that you can learn something from this session that maybe you can reuse in the future. So for the record, this is the first time that I'm coming in Serbia. So I'm counting on you after our speak to give me some wonderful activities that I can do in Belgrade. So my name is Benjamin and I'm a solutions architect working for AWS for almost 2 years now. And I usually work with grown-up startups that were born with the cloud. You may have noticed by my accent that I may come from France. Most of my customers are also located in France. And one of my customers, Augury, that has offices also in Belgrade, so that's why I'm here today. For the topic today, I wanted to speak about AWS Cloud Development Kit. In the first part, I will give you an overview and what new feature we had these couple of months back then. And then we are going to speak about the constructs, which is a fundamental notion when you are using CDK. And after, I will do a quick demo for you to see how you can get started with AWS CDK. I'm hoping that you have some knowledge about infrastructure as code. So in this slide, I will present you the evolution of the tooling that we have been using, that we are still using today. It all starts with manual deployment. This is where you are using wikis or playbooks to deploy your infrastructure. Maybe you can relate an experience where you have to use this kind of manual process, but sometimes it was outdated or you were lacking details that will fail the deployment afterwards. Your best chance to get it working is that to ask the person that did it. And so you have to be lucky. Is this person not on vacation? Is this person still in the work in the company? Next, we have been using scripts, mostly in Bash. Everything worked well, but you know Bash is not optimal to do deployment. It was not built for this to start with. And so the best thing you could say to your teammates was, my script works fine, don't touch it or you will break it. The next big evolution in the chain was with declarative way. If you're used to using CloudFormation or Terraform, this is what I'm relating to. So you are using engines such as CloudFormation or Terraform, and then you are describing your infrastructure in a declarative way. So using JSON or YAML, depending on what you are using. These engines bring you more fluidity. They bring you things like rollbacks. They bring you things like error management, and that's why they are powerful today and that we still use them today. The missing feature of this declarative way is that you can end up with a template that is thousands of lines, and when you have to modify it, you're going to get some trouble, remember, depending on the last time you modified it. In the next step, we use what we call generators, and that's simply a way to generate your JSON code or YAML code using a familiar programming language, such as Python. And then on top of that, with recent things, we have, for example, AWS CDK or Pulumi, if you know, and that's what we call abstractions. So if we take CDK, and if you want really quick definition of what is it, you really have to view it as a layer of abstraction that goes on top of CloudFormation, which means that you will write code with CDK, and where you are going to make an operation that is called a synth to synthesize your code. You are going to have an output in CloudFormation, and it will generate your template for you. One important thing that I wanted to mention is that I am not saying that using JSON or YAML is a wrong way, but with CDK it's a different way, and you should be working with the tool you are comfortable with. And we will see that even CDK, it has its strengths, it has its drawbacks. So depending on your team, what your team is using, it's good to go from one on another. To dive deep on Cloud Development Kit, CDK, it's an open source software development framework to model and provision your infrastructure and your cloud resources. To emphasize on it, you really have to view it as an abstraction layer that goes on top of CloudFormation. In terms of programming languages that you can use for CDK, you can use Python, JavaScript, Typescript, Java, C# or Go. You have this freedom to use these languages to provision your infrastructure. In the end, you will get CloudFormation template that is similar to what you were doing maybe yesterday. And also, if you look at CDK, you have all the tools that you were using before. So if you're using an IDE, you will have the autocomplete, you will have the debugger, you will have the documentation. This is how it will make faster for you to deploy your resources. One of the highly requested features was the support for Go. So if there is Go developer here, you can be happy that it's recently got stable and generally available for you. When you want to build with CDK, we are going to see that there is this notion of constructs, and a construct, depending on the level of construct, is going to provide you with a layer of abstraction. And we are going to dive deep on this later. But when you're using construct, it will have default values that has already some best practices around security, for example. And so if you take a look at the components of AWS CDK, in first you have the core framework. On top, you will have your application. So this is where you are going to code with CDK. And then it's going to generate stacks. And these stacks are going to generate your resources. And so this is a mapping one-for-one between CloudFormation stacks. And it's always a good practice to divide your resources. For example, you're going to have one template for your network infrastructure. If you are creating, for example, your VPCs, it's always a good practice to separate this. Then you have the construct library. So it's a set of components that was built by AWS that can help you to provision your resources. And depending on the level of the construct, you're going to provision more resources with less code. We're going to see an example with a VPC. At last, you have the CDK CLI. So that's how you are going to interact with CDK. You may be wondering how the workflow is orchestrated. So it all starts with a CDK init. So with the CDK init, you are going to initialize your project structure with your specific programming language. So for example, Python or Typescript. And then after you have done your init, you can start building and you can start adding stacks and creating your application. And so after the init, you have to build your project. If you are using Typescript, you are going to run npm run build. And then you are going to synthesize with the command CDK synth. This is the operation that's going to translate your CDK code to a template of CloudFormation. If you are updating your version, you can do a CDK synth to see what resources will be updated, deleted, or created. And then you are going to run a CDK deploy. So this is where your changes will be pushed to CloudFormation, and CloudFormation is going to take it from here. And then it's going to deploy and provision your cloud resources. So that's how CDK handles the workflow and how you can use it. As you can see, there is a shift of paradigm because you are not using the same way that you would with CloudFormation. So with CloudFormation, you will have, for example, one big template, maybe with some nested stacks, but you're gonna have maybe one big template with lots of parameters to deploy your environments. So for example, your development environments, your staging environments, your production environments. But with CDK, you're all gonna start with your application, and then it's going to provision templates and then the associated stacks. And you can bring all the power of your custom languages. So the example that I prefer to say is the loops. If you're trying to deploy two VPCs with CloudFormation, you're gonna have to copy and paste the stacks maybe. But with CDK, you can just make a loop and it will generate the two VPCs for you. If you have been using CDK in the past, so there is a version 1 and a version 2. So the version 1 came out in 2019. And the version 2 came out in 2021. And the biggest difference between V1 and V2, we have simplified the dependencies, meaning that in the V1, you had to import all the dependencies. There was like 200 dependencies, roughly one per service. And we have simplified this approach to have only one package for you to import. When you want to migrate from V1 to V2, it's straightforward and you don't have many operations to do so. Another new thing is that we have improved the coverage of the services. For example, we have more layer 2 constructs. We will see what are the layer 2 constructs just after. We have graduated other constructs from an experimental or developer preview to a stable state, meaning that you have insurance that it will be backward compatible if there are changes in the future. And so among the services, if you are running Kubernetes clusters, we have layer 2 construct for Amazon EKS, for CloudFront, and other services like OpenSearch or AppMesh. You can see that CDK is followed by a community, but it's also closely followed by AWS based on the feedback that we get from our customers. We have graduated Go support to GA, to generally available. And if you are wondering, so if I were using the V1, if I want to go to V2 but still keep some V1, we would still support V1. As you can see, in the number of open source community contribution over the past years have significantly risen. If you have any questions so far, you may ask, and maybe we can dive into the construct, which was the notion really important when you are dealing with CDK. Just to get back to the construct library, which was one of the 3 components of the CDK. Basically, the library represents AWS resources. For example, if you have an S3 bucket, in the library it's going to be s3.bucket. It's as simple as this. This library is the starting point where you are going to dig maybe in the documentation to get the right resources to deploy. And so to get to the construct level, there are 3 levels of construct. The first one is the CloudFormation resources. So L1 construct are simply one-for-one relation between what you are going to input in CDK to resources in CloudFormation. And then on top of this, you have the L2 construct. Maybe to give an example, at the L1 level, maybe you're going to provision a VPC, but a VPC alone can't do anything. Afterward, you have to create your subnet, you have to configure your route tables, you have to do your associations. So at the L1, you will only get the VPC, but at the L2 level, you're going to get a fully working VPC only with a single line of code. And because we have created these constructs that are pre-built by AWS and that you can use and with sane default parameters, but you can also customize them. So we saw L1 is for single resources, L2 would be for a service that you want to have pre-built, and L3 would be if you want to have multiple services deployed in a pattern, for example. That's what we call opinionated abstraction. So let's say that you want to deploy containers with ECS. At first, you need your VPC. Maybe you need a load balancer in front of your containers, and then you need to provision your ECS clusters. So that's where you can do L3 constructs. L1, single resources. L2 would be for a single service, and L3 would be multiple services coupled together. To give you an example of L1 construct, here you can see that I'm calling new CFN bucket, and I'm going to give this bucket a name. When you do CDK synth, this is what you're going to get in CloudFormation. If you want to get the best of CDK, maybe the L1 is not the right construct level to use. Now, if we take a look at the L2 constructs, so here I'm calling ec2.vpc, and you're going to see that if I do a CDK synth, it's going to deploy all of this. So it's going to deploy your VPC, your subnets, your internet gateway. It's going to do the associations. You're going to get your routing table. You're going to get your NAT gateways with the elastic IP behind. With this L2 construct, we have same default values, because it's mostly what customers are using. You have your public subnet, you have a private subnet, you have your NAT gateway. That's common pattern, but everything is optional, meaning that you can customize if you want 2AZ, 3AZ. So you get a ready-to-use VPC with a single line of code. And so to dive deep also on the L3 constructs, this is where you want to create a pattern for your containers. In order to have your containers running, you need your VPC, you need a load balancer in front, you need to have your task definition with your image. You're going to say, I want this amount of CPU of memory, and it's going to provision with default parameters, also with your security groups that can be deployed. When you are using constructs in the documentation, you can see if the construct is in experimental or developer preview or stable state. So you should be aware when you're using experimental or developer preview, because if there are changes in the future, you may have to update your source code in the future. Once you are in a stable state, we make sure that it's backward compatible if we are making updates on this construct. Probably assume that many of you are already using CloudFormation. And if you are using CloudFormation, you can get started with CDK and you can import your templates directly into CDK. For example, you're going to give the file path, and after you can modify directly your resources that is in your template. Maybe one point of attention is that if you are mixing L2 and L1 construct, you may have some difficulties to do so. That's one thing to keep in mind when you are working to import your CloudFormation templates. For example, we have a platform where we store some common pattern that you can pre-use. If you're trying to deploy an API gateway with a DynamoDB table, you can use to get started quickly. And the thing to say behind this is that it's open source and there's a community behind it. So you can use construct that people have also built. We have this construct hub, and so on this you can see the contribution, for example. And if you want to have your own construct hub internally in your company, you can also build your own. We do have an open ecosystem. The roadmap is open, so you can see what currently the service team is working on. Of course, the future changes on CDK will be based on your feedback. If you think that there's something missing, you can raise something on the GitHub, or even if you are working with AWS, if you have an account team, you can ask for changes, and we'll make sure that your voice is heard. We also have a Twitter page where you can follow some news. And so we know that a lot of customers are using Kubernetes. So if you are using Kubernetes, there are also the CDK for Kubernetes that you can use. When you do a synthesize, you're going to get a standard Kubernetes manifest that you can deploy on any cluster. And it's a CNCF sandbox project, so you can follow this project. We know, for example, that if you're using CloudFormation, probably you are only on AWS, but for some people that are running multi-provider, they are often using Terraform to use multiple provider. And so we are also working with HashiCorp to have a support for CDK for Terraform. You're going to get your construct using the Terraform engine. I just wanted to move to the demo, just to show you how you can get started. For this demo, this is the setup that I have done. I have around 50 lines of code in CDK. And basically, I'm going to provide a VPC with 4 subnets, so 2 private and 2 public. And I'm going to provision an instance. When I'm going to do the CDK synth, I can look at the templates and it's going to be 1,300 lines. If I want to repeat this pattern of this VPC with my subnets, I can simply do a loop to get 2 VPCs with my instances. So at first, I'm going to make a directory for my project. So mkdir. Okay, I'm going to go in this folder. And I'm going to do init. So if you remember the development workflow, at the beginning we had the init, and you can say, I want to use this programming language. So I'm going to do an init, sample app, and then you can input your language. And so it's going to create a virtual environment for you to use after. And if you look at the project structure, you're going to have app.python. And this is your main entry point. And if you look at it, you're going to see that we are importing a stack. This stack is going to be what you want to modify. So if I go So yeah, so for example here, so this is a sample app that is given. And for example here, we are provisioning an SQS queue. I'm going to modify some code and explain what I will be adding on top. Just going to activate my virtual environment. Okay, I'm just going to install the requirements if it's not already installed. Okay, so okay. So just installing the requirements. Okay, and so now I'm going to move to the modification of the code. I'm going to copy and paste some of the code and I will explain what I'm doing. Because I'm going to deploy my VPCs, my instance, I only did EC2 and IAM. Why IAM? Because to deploy my instance, I want to do it with System Manager to avoid opening maybe a SSH port or having an EC2 keeper that I have to handle. This is your class that you will be working in. This is your function. I'm comfortable with Python, so I went with Python, but honestly, you can use any language that you want. I like to work with lists. So for example, I have the first CIDR block for my first VPC and the second one. I also have my VPC name list. So I have 3 lists describing the necessary components to deploy my infrastructure. I'm defining also my AMI, so which AMI I'm going to use for my EC2 instance. So you can do it this way. So I'm using Amazon Linux 2. I'm defining my role that I will be for the instance profile. And you can see that it's instance SSM, so it's to use system manager behind. And here it's really the interesting part. So I'm just going to do a loop based on the range of my lists, and I'm going to create my VPC. So if you remember the L2 constructs, this is what I'm calling, and I'm just changing some parameters to adapt to the loop. The ID of the resources is going to take the name of this one, and I'm giving the CIDR, and I'm giving the name of the VPC. And afterward, I'm going to create an instance in one subnet of one of my VPC, but it's going to do it in both VPCs. Maybe one question that you could ask is if I want to be precise in which subnet I want to deploy my instance. You have a method that you can call that is called select subnet, and then you can select any subnet depending on its name, on its availability zone. So I'm going to save the changes. And so so we have done our init, we have done our code change. Now we are going to do our CDK synth to see what will be provisioned in terms of CloudFormation template. It may take a while, so I have an error. Okay, just because I copy-pasted this code, I need...
It's a different name.
Yeah, it's a different name.
You're exporting Python CDK workshop stack, and it's exporting CDK Python project stack.
No, not this one. The name of the class is this. Yes, because I tested this a couple of times and I reached the VPC limit, the default VPC limit. So I wanted to delete the other stack before I'm getting stuck with the default limit. So here it's done. And so you can look at this, if I remember correctly, it's in CDK out, and you can get the template. So this is the template that will be passed to CloudFormation for the deployment. And so if you look at the number of lines, it's more than 1,300 lines. So this is where you're going to win speed and efficiency depending on your use case. So once I did a synth, I can do a CDK deploy. Okay. And so if I look at CloudFormation now in the interface, I should be able to see that is in review and it should be deployed afterwards. So the time it deploys, I'm going to switch over to the presentation just to show you how you could structure your CDK application. We saw that with a simple loop, I've deployed two VPCs, two distinct VPCs, and you could also go further with some additional more setup, but we could see cross-region deployment, cross-account deployment. It may need some additional setup, but it could be done in one CDK application. For example, we have a blog post where we give some recommendation with Python of a project structure. And so, for example, if you're trying to deploy an API, you would divide your structure. For example, you would have a folder with your database, and inside each folder, you will have your infrastructure.python. If you like to have a central place where you have all your constants and all your values, you can also have a constant.python. And if you want to deploy a CI/CD pipeline on the same time to see if change have been made, you can deploy it directly with CDK also. So we have the pipeline, we have the deployment, and we have all our blocks. So the database, the monitoring, the API. We also have a runtime folder, which will contain maybe the code of our Lambda function. If you need more information, you can easily find the blog post with this QR code, or if you type Python CDK project structure. I'm just going to check the demo. So what takes the most time is the NAT gateways, because they need elastic IP and it takes a few minutes to provision. If I go to VPCs, I should be able to see my VPCs now. Okay, so I have demo VPC 1 and VPC 2. So here it's how you can use a CDK. To have a critical eye on CDK, it may suit your needs, it may not suit your needs, but it's going to get you faster if you have repeatable steps in your infrastructure provisioning. If you take the strength of CDK, is that you can use a familiar programming language, but let's say you are in a team, you are using Python, your colleague is using Typescript, and if you want to work together, you're going to agree on maybe which language you want to use for a common base. The advantage of gaining more freedom also is a drawback. If you want to use it in team, you also have to agree on which language you want to use. If you are using JSON or YAML, you don't have to ask this question, because switching from JSON to YAML is easy and fast. CDK is a really nice tool if you want to repeat steps in deploying your infrastructure. We are coming to an end. I hope you have learned some things. The best way to learn when you're working on AWS is to get practical. We have a dedicated workshop with the different languages and where you can follow and see if it may suit your needs in your team or for you as an individual contributor. Thank you for your time.
For the import part, so I know that we shouldn't really mix it with the higher level constructs, but for the low level resources, do you think it can be used regularly or just maybe for some situations?
I mean, for some situations it's going to be useful, but using lower level constructs you're going to lose the value of CDK.
Yeah, but I mean, if you have some templates that you need to
import,
yeah. So that works correctly.
Yeah, it
also
works.
all new stuff which is coming to AWS. Just for example, something came up yesterday. You can find it in level 1 constructs, but no L2 constructs for a long time.
Yeah, but what about how's the code help me? The AWS native API. What's it called? The new API where you get all the latest
cloud API.
stuff.
Yeah. You can call. You mean unified cloud API to call all the services? That's something that came up like 6 months ago.
Yeah, that one. Is that supported by CDK or not yet?
Not sure.
No, it's not related. CDK works with CloudFormation. You generate CloudFormation, and then you deploy CloudFormation. CDK does not call API. It's not Terraform.
That's where problem is better.
Yes, that's the main difference between Terraform and, for example, CloudFormation. Every API call is going through CloudFormation. Instead, Terraform is going to call directly the services API. That's one of the main differences that you get between and because CDK is using CloudFormation, it's the same thing. Yes.
Sorry. Nice segue. I just wanted to ask, do you have some experience with Pulumi, and would you just compare latest version of CDK 2.0 and Pulumi in your opinion?
Yeah, I've not done big research on Pulumi. I've just seen that it's multi-provider, so it's for every cloud provider, so you can use it fluently with many providers. So that's the main difference that I've noticed on the surface, but I've not done some big research on it.
Yeah, my colleague and I have done some extensive work in Pulumi, and I have to say, I'm sorry, AWS, but it's better. It's better in every way.
But who are you paying at the end?
I'm not paying. Yeah, of course. I mean, I want to, feel good.
Yeah, but the main difference I think would be that what we were just saying, Pulumi can also call on Terraform or call on the native APIs or something like that. So we can
you get the latest stuff the moment it comes out. You get the most up-to-date stuff. Also, the languages are being used in a more idiomatic way. You don't have shit like classes, this stuff like that. It's a function. You just call a function. You get what you want. You can use your language the way you want to. There's not much boilerplate.
Yeah, but this is something different.
Yes.
This is something that generates CloudFormation.
Yeah,
This is exactly what, because I said at the beginning, you should choose the tool that you are comfortable using. Of course, if you are in multi-provider approach, you're not going to use CDK, because what about the other provider?
For me, maybe not the biggest selling point for a tool like this is the iteration and repeatability and modularity. Terraform can do everything, all of that, with modules, with iterations, with everything. The main selling point for a tool like this, for me, is the actual DevOps practice that you get. You actually get a true collaboration of developers and operations people, because they can speak the same language, they can work on the same stuff. It's really great.
In our team, developers do the CDK part also.
Yes. Yeah. It's great.
Same repo and same thing.
Yeah.
You need a cube, you make cube.
That's the biggest selling point for a tool like this.
It depends on the situation. Are you really using the CloudFormation, and do you really have a problem with developers understanding the usage of, for example, Terraform and trying on their own to provision the infrastructure and their services and so on? But I guess depending on the situation, yes, it's really cool. I think we have some more questions though. I just
Yes, this is you mentioned cooperation with HashiCorp, because another
CDK for Terraform.
When you integrate with CDK with Terraform, and then you can choose multiple cloud provider, and then you are using language on your own, for example Java, Node.js or whatever, with plugin that can deploy it to the different like Google Cloud, AWS. Then it is something for me as always I was not to be stacked. In AWS, in Oracle, on Microsoft or Google, whatever stack, then this is tool that I will maybe think about it.
Yeah.
Because as always, situation is not so simple. There is lots of legacy, lots of buying. If you're a big corporation who is buying companies, some one day you choose AWS, and then they're buying company with Google Cloud things, and then of course you are a guy for this, for that, but as always, you need to do with the legacy, with HashiCorp plugin. I think that maybe one day you can, do what Terraform do now, make Terraform script and then play it. And now you can play it, for example, with Java, because your developers understand Java, and that's it.
Yeah, the thing is, we don't really need Terraform anymore. I don't want to use the HashiCorp language, I don't care. But the second problem is that all of these tools, if you want to go multi-cloud, whatever deployment environments, you need to go through Terraform still. Pulumi goes through Terraform mainly. And then you can use the AWS, what's it called, the API, native API, and stuff. But it mainly goes through Terraform still.
But you have this layer of abstraction that.
That's the other
you
one.
it is abstraction. After that, you're dealing with a native code, JavaScript or something, of course. It's always, you know, when you're programming in C, you are, you know, a native language using after that. But for me, assembler is, you know, past. But everything go there, you know. For that, Terraform is one step in.
But also, what can be good for CDK, if it's the same defaults, the good defaults are for me really important, because when you're using some of these other things, you don't really always get the good defaults, and sometimes the default is what shoots you in the leg. And if you didn't, if you paid a bit more attention, you wouldn't have a problem. But if you trust the default, almost always you will have a problem. So that's really important also.
Yes, because when you're starting, you may know, you may not know. Okay, my VPC, it has to have public subnet, private subnet. The only difference between a private subnet and a public subnet is only the route behind it. So you can easily do a mistake, or you can easily do something that was not intentionally wanted for the security afterwards.